Happy New Year, everyone. It is finally 2021, and I hope we are over the worst part of 2020, which was the pandemic. But I'm starting the new year off feeling good. I have new mouse ears, and I'm not going to move closer, but I'm going to move my computer closer. Like, they're fireworks. They're pretty awesome. They're velvet. They're so awesome. My favorite colors are hot pink and black, and so that's even better because there's this firework, and they're exact same on the back. But anyways, I just want to wish you guys all a Happy New Year. I hope this year is better for you, and I hope the year brings health, wealth, and happiness. So, starting off the new year with a new chapter. Chapter 6 is on exponential functions. This is actually one of my favorite chapters because we learn decay and growth. Some of the other formulas. What else do we have in there? Compound interest. And we talk about how things grow exponentially and what that means, versus how things can grow with a constant rate of change, which would be linear. Now they're growing, exponentially. So what does that mean differently? And so chapter 6 is about exponential functions. Chapter 6.1 specifically is talking about square root properties. So here we go. We're going to learn some new funky ways of working with square roots today. I keep wiggling. That's the square root properties. It looks kind of like mumble jumble right now. Whoops. Sorry about that. So there's a couple properties. I don't really call them by name, but I will write them out. The first one is the product property. The product prop of square roots. Looking at this stuff backwards, it's like, oh my gosh, how can you guys read my writing? That's a radical. Anyways, so what this property says is if you have a product, hence product, with under the square root, you could take it apart and you could put it back together. So if you have the square root of x times y, it is actually equal to the square root of x times the square root of y. Now, the only thing you really need to know right here is y has to be greater than or equal to 0. And you're going to see what that looks like. So you have a product, and you can pull it apart. That's really what it is. And if you could pull it apart, you could actually put it back together. So this property, it goes kind of both ways. Okay, it's kind of circular. And same thing with the quotient. So the quotient property. Quotient prop of square roots. So if you have a quotient of, let's say, the square root of x over y. Notice everything is underneath that radical. So you have the quotient of x over y. If it's put together, you could take it apart. So that's going to equal the square root of x over the square root of y. Whoops. Now on this one, both x has to be greater than or equal to 0, and y has to be greater than 0. Because remember, you can't have 0 in the denominator of a fraction. It becomes undefined. So just remember, x has to be greater than or equal to 0. So you can't have 0 in the numerator. Y has to be greater than 0. Okay? So basically, if it's put together, you could take it apart. And if it's taken apart, you could put it back together. So these are your two properties. My kids, these are blue. I almost forgot the colors there. So you might want to have your calculator handy. I'm going to already erase this. Hopefully you guys got this down. If not, hit pause. And the sun is kind of going away. My light is kind of dissipating here. We're supposed to get like 2 to 4 inches of snow today, and now they keep changing it to like a ½ inch, so who knows what's going on. So here we go. Example 1. We're going to simplify. Now remember, when you simplify, you are doing until you can't do anymore. So keep your calculator handy. Hopefully you know how to use the square root symbol. If you don't, let's look for this. You're looking for x squared. See that right above that yellow square root? So you're going to hit second x squared. And that will get you, there it is, that'll get you the radical. Okay. But first, we got to think about squares and square roots. So that 30 by 30 multiplication sheet that I gave to you in the beginning of the school year, you might want to use that. That is going to be a quick, easy reference for this. Hopefully you guys got it printed out. If not, it's a great resource still just to look at. But if you can, I would print that out and start looking at it, because this is going to be an easy way to find factors. Because what we're going to do is we are going to break down radicals today. Now remember, this guy is a radical. What is underneath is the radicand. Okay, I'll put that off to the side. So we're going to simplify the square root of 150. And I'm going to do this off to the side. So this guy is the radical, and that guy is the radicand. Is that music too loud? Just for reference. Okay, so we're breaking down the square root of 150, and we're not just going to hit the calculator. Oh, second square root of 150 is approximately, what is that? 12.2, blah, 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 blah. No, we're not doing that. So when we simplify them, what you're going to do is you are going to look for factors of 150. And there are all kinds of factors. So I'm going to start listing. 1 times 150. 2 times 75. 3 times 50. Does 4 go into it? I don't think so. See, this is why that sheet comes in handy. Nope, it doesn't. Not evenly. 5. 150 divided by 5 goes 30 times. 6. No. And remembering your divisibility rules. Oh, yes, it does. 25. My bad. Knowing your divisibility rules was really going to help this a lot. 7? 20. Nope. 7 doesn't work. 8 doesn't work. 9. 10. Yep, 10 works. 10 times 15. I don't think there's anything else. 5, 6, 9 doesn't work. Okay. So what I've listed factors. Now here's the thing. When you simplify a radical, you can start with any pair of factors you want. It will all work. But it just depends on if you want to do a lot of work or if you don't want to do as much of work. And so what I tell my kids, the best possible option of factors is a perfect square and a prime factor. Those are the best options you want when you want to simplify these guys. And you know what? I would never start with 1 in the number. That's not going to get you anywhere. You can't do anything with that. Okay? So 2. 2 is prime, but 75 is not a perfect square. Although this is going to be a good pair. 3 and 50. Prime, not a perfect square. Still a good pair, but let's see if there's a best. Prime, not perfect. So these 3 are kind of the same. 6. Nope. 25 is a perfect square, though, so that works. And 10 and 15, these all work, but this one right here is going to be the longest. So what I'm going to do, since I can't find that prime factor and the perfect square factor, the next possible is either going to be a prime with a composite or a perfect square with a composite. And so what I'm going to do is I'm going to pick this pair right here. And there are so many ways you can attack this problem. Many different ways. Prime and perfect is your best option. If you don't have prime and perfect factors, then I go perfect with a composite. Okay, here we go. So I'm going to use 6 and 25. All of these will work, and I'm going to show you what it looks like later. So here's what we're going to do. We're going to break it down. So if it's put together, now we're going to take it apart. So I'm going to go, it's going to be the square root of 25 times the square root of 6. You could put 6 first, or you could put 25 first. Doesn't matter. I like my kids to put the perfect square first because you can simplify this faster. So we're going to simplify the square root of 25, which is 5. Square root of 25 because 5 times 5 is 25. And then you're going to simplify the square root of 6. Well, what are the factors of 6? 1 times 6 and 2 times 3. So if you break this down to 2 times 3, what you find out is you can't do anything more with this. And so, since this square root of 6 is composite, but yet the composite number has prime factors, you're going to leave it like this. So your answer is 5, whoops, I'm trying to do 5 and a square root. 5 times the square root of 6. That is going to be your final answer, because when you break down root 6, you get prime factors. And you can't do anything with that, so you're going to leave it like this. And this is all going to be really weird, but you're going to get lots of practice on this. So when you simplify the square root of 150, its simplified form is 5 times the square root of 6, also known as what I say 5 root 6. and 5 is being multiplied by the square root of 6. It works with any of these, but let's try 10 and 15. Watch how crazy this gets. Okay, so let's go square root 10 times square root 15. Let's say we picked these, and this is hopefully this will divert you from picking composite and composite. Okay, so square root of 10. Square root 5 times square root 2. 15. Square root 5 times square root 3. Well, you have square root of 5, square root of 5. So if you have the square root of 5 times the square root of 5, that's known as the square root of 5 times 5 times the square root of 2 times the square root of 3. Simplify this. Well, you have the square root of 25 times the square root of 2 times the square root of 3. Simplify this. Square root of 25 is 5. 5 times root 2 times root 3. Well, that is root 6 broken down. Where'd you go? There you are. And so you end up with 5 times the square root of 6. You still end up getting that. But it's just a longer process. And not only that, but you really got to know what you're doing here on breaking down square roots. So that's why I don't recommend composite and composite. Your first option, the best possible, prime factor and perfect square factor. If that's not an option, then my choice is perfect square and then prime. That's why I chose this one. These would have worked too. You just had a little bit more room. A little bit more, not room, a little bit more work to do because you have to break down bigger numbers. We're going to do a couple more. But I'm not going to do this composite thing anymore. I just wanted to show that to you. You're going to see how these can get big and gnarly if you pick composite factors. So let's go. I'm going to do a quotient one. This is still example one. So you have the square root of 15/64. It's put together. Now we're going to take it apart. So you have the square root of 15 over the square root of 64. Let's see if you can simplify anything first. Square root of 15, not a perfect square. Square root of 64, it is a perfect square. So you're going to take the square root of that. So you have the square root of 15 over 8. Look to see if you can simplify the square root of 15. Well, what are the factors of 15? 1 and 15, we're not ever going to pick that because it's never going to take us anywhere. And then the square root of 15 is also root 3 times root 5. Root 3 times root 5. But look, these are prime factors. So you're actually going to leave the square root of 15 as the square root of 15. Because this has prime factors, and this is already actually simplified. Even though it doesn't look like it, it's already simplified. So that would be your final answer. Sometimes they can be that fast. Now, we're going to pick some other random numbers. Let's break them down. And this is going to be NIB, not in book, because I'm just going to start picking numbers. We're still going to simplify, though. So let's go, let's simplify the opposite of the square root of, I don't know. How about, what numbers are in here? How about 80? Actually, that's in the book. So the opposite of the square root of 80. If you have a negative sign, it has to be outside the radical because as soon as that negative sign, wordy here. As soon as the negative sign moves inside the radical, you can't do that this year. That's Algebra 2 material. Okay? So the opposite of the square root of 80. So you're going to bring down your negative. Don't worry about that sign. Okay, now let's think about factors of 80. So 1 times 80. Remember, it's not going to get us anywhere. 2 times 40. 3 doesn't work. 4 times 10. 5 times, and see, this is why that sheet's going to come in handy. 80 divided by 5. 16. 6, 7 doesn't work. 8 times 10. And there we go. All right. And when you list factors, you want to put them in order so that way you don't forget a number. It's so much easier if you go in order, chronological order. 1 times 80, that's never going to get us anywhere. Okay, so now we're looking for prime and perfect. Those are our best options. That's prime, that's not perfect. Ooh, that's perfect, but that's composite. So hang on to that one. That's prime, that's perfect. We like this one. Ooh, composite and composite. Your last possible option is a composite versus a composite. It's just you're going to get a lot of work, and if you don't quite know how to put them together and take them apart and what you can put together, what you can't take it apart, it's going to get super confusing. So, I don't ever want to tackle composite, to be honest. But sometimes that's the only route you have, and you just have to work on it. So I'm going to go 5 and 16. Watch how fast this goes. So I'm going to put the perfect square first. So I have root 16 times root 5. You can bring down the sign. Don't worry about the signs. If they give you a sign, just include it in your answer. Okay. Now simplify the square root of 16, which is 4. Now the square root of 5. The only factors of 5 are 1 and 5, so it's already simplified. And we're done. So if you simplify the opposite of the square root of 80, you get, remember, you can say negative, negative 4 times the square root of 5. That's its simplified version. Or you could say the opposite, 4 times root 5. And that was actually, number 2. So this is why you want prime and perfect. Look how fast that goes. Because once you get your prime factor, it's already simplified. You can't do anything else with it. When you get your perfect factor, you want to put that out in front and take the square root of that. Take the square root of that. Okay. I like how fast these go. That's the best. Prime and perfect. So, prime, perfect. I'm going to write this. Here are your options of factors. Prime and perfect is first. And when we're done here, guys, this is going to be blue. Prime and perfect. That's your best option. But if you can't get a prime and a perfect factor, then you're going to go with a perfect square and composite. Is that what we had last time? Yep. And then prime composite. That would be like 2 and 40, 4 and 10. And then last but not least, composite. These would be the order of, I think, what would be the simplest and also probably the least amount of work. Prime perfect. So circle that, guys. Make that in blue. And I'm cruising on. Because this part, you're going to get more practice of this in upcoming problems. So example 2. Here we go. We're going to start using this square root, this radical. We'll start simplifying more. Simplifying, evaluating, all kinds of stuff. So example 2, we're going to evaluate. So what's the difference between evaluate and simplify? Simplify. Do until you can't do anymore. Whatever that entails. Evaluate, remember 3 words. Do the math. So evaluate. Here we go. A is 2, B is negative 8, and C is 4. You are going to see this later on in chapter, I want to say 9. Maybe 8. I don't know. Here we go. You're going to have the square root of b squared minus 4ac. So what you're going to do, evaluate this problem, it's like a little mini plug and chug. So you're going to plug your values in, and you're going to chug through the work. So let's fill in b, a, and c. So we have the square root of b, which is negative 8 squared. Notice I put that in parentheses. Because you're squaring whatever b is, and b is negative. So it's important that you remember what you're squaring and where the negative is. That's b squared minus 4 times a, which is 2, times c, which is 4 again. You want to make sure your radical is long enough because this is all being done underneath that radical symbol. Here we go. Let's start simplifying. So the square root. Negative 8 times negative 8 is 64 minus 4 times 2 is 8. 8 times 4 is 32. So you have the square root of 64 minus 32. You're going to do everything underneath the radical first. And then when you get to just a final number, that's when you're going to simplify that guy. So square root of 64 times minus 32. So you have the square root of, what is that, 32? But you can't leave it like that. You're going to now simplify this guy. So we got to think of our factors. So 1 times 32. Remember, that never gets you anywhere. So I wouldn't even do 1. Don't. So 2 times 16, 4 times 8. Those are our only factors. So remember, prime and perfect is your best. 2 times 16, prime and perfect. You can't get much better than that. So here we go. Let's go 2 times 16. So we have the square root. You're going to put your, that's a little big. You're going to put your perfect square first. So square root of 16 times the square root of 2. It really doesn't matter which one you put first, but I put this one first so that way you can simplify that part. So the square root of 16 is 4. And you can't simplify square root of 2 because it's already simplified. So you have 4 root 2. Remember, it's 4 times root 2. There's your final answer. So you're going to substitute your values in. Do all the math underneath the radical first. When you get down to just a radicand, then you're going to take the square root of that. But you're not going to do the square root of 32 on your calculator. No. You're going to simplify it. So you're going to find your factors. List your factors. Look for the best possible pair. 4 square root 8 does work. I'll show it to you. So my kids, don't copy, but watch. So if I want to do square root 4, square root 8 for square root of 32, so I would go root 4 times root 8. Just watch. So root 4 is 2, right? Now square root of 8 is square root 4 times square root 2 because we know 8 and 1 is not going to get us anywhere. So here we go. We're going to simplify this. So we have 2 times root 4 is 2 times root 2. Well, 2 times 2 is 4. 4 root 2. You still get the same answer. But you have to really know how to work with radicals on this. So that's why your prime and perfect are the best option. All right. I'm only going to do one of these because I want to get to the next few problems. But just know that you substitute your values in. Do all the work underneath the radical first. Be careful of what you're squaring for b. And then simplify this guy. So, example 2 actually has example 1 in it. You get more practice of simplifying. Basically, what you do is non-perfect squares. Sometimes they'll throw in one like square root of 100, and you're like, oh, I got to break this down. Guys, just remember your perfect squares. They might throw one of those in. They get sneaky sometimes. Okay. But really what we're doing today is we're learning how to break down non-perfect squares and simplifying them with radicals. That's what we're doing. Okay, example 3. Now we're going to use some expressions. So we're going to have factors, we're going to have terms, we're going to be adding and subtracting stuff, and you're going to want to do something that you can't, and I'm going to make sure I highlight that. So here we go. Example 3 is simplify. So remember, do until you can't do anymore. You can no longer just leave your answers like the square root of 17, square root of 51, whatever it is. You can no longer do that. Well, square root of 17 actually is simplified because that's a prime factor. Prime number. Anyways, here we go. We have 6 plus the square root of 8 all over 2. Here we go. Let's simplify this expression. Remember, it's an expression because there's no equal sign in it. An expression is made up of terms separated by addition and subtraction. So the first thing you do is you're going to break down root 8. 1 and 8 aren't going to get you anywhere, so we're going to do 4 and 2. Remember, you're going to put square root 4 first because that's your perfect square. So 6 plus root 4, root 2 over 2. Now you're going to look to see what you can do. Can't do anything with this guy yet. Here we go. We can simplify square root 4. So we got 6 plus square root of 4 is 2. 2 root 2 over 2. Now you're looking to simplify. Here's the one thing you cannot do. And I'm going to circle this. Right here. Do not do that. Do not do. Because it's the difference between factors and terms. If you need a vocab lesson, make sure you look that up. Don't do 6 plus 2, because 2 is actually being multiplying by square root of 2. So 2 is actually a factor of root 2. So you have a term and a factor. You can't simplify those. But you're going to want to, because it looks like you can, but you cannot. So just make sure you don't ever do this. So what can you simplify? This is going to be the weird part. So I'm going to rewrite this. All right. Factor, factor, factor. So how many times? You can simplify 6 and 2 and 2 and 2. So 2 goes into 6 3 times. It goes down here once. But remember, you can also simplify 2 and 2 here. So 2 goes into 2 once. So you have 3 plus, if you have 1 root 2, do you think you'd use that 1? You do not. Root 2 over 1, because there's a 1 down here. Do you normally see 1s in the denominator? No. So your final answer is 3 plus root 2. Boom. Now some of you guys may be asking, why can I do this with the 6 and the 2 here, and then also the 2 and the 2 here? Here's why. This is the same as. Same as. And this, I think, will help you be able to see it easier. 6 over 2 plus 2 root 2 over 2. That's the same. So that's why you can have, well, 6 divided by 2 is 3. Plus, and then you have 2 divided by 2. That's what you can simplify, 1 and 1. So you have 3 plus, well, this is 1 root 2 over 1. That's just root 2. You don't use 1s in simplifying radicals, just like you don't use 1s in anything, really. So that's why you can simplify all this together, because it's this over that. Sorry, this plus that. Sorry. So remember, it's the same as over here. Let's do another one of these. I know today's a little bit long, but remember, do not add those, and you can see why you can't do that here. But it's going to be tempting to do it, but you can't. Sorry. Okay, let's go. I've already used that number. Simplifying. So let's go 2 minus the square root of 28 over 6. This is an OYO. Here we go. Let's start breaking 28 down. So we have 1 and 28. You're never going to use that. 2 and 14. 3 doesn't work. 4 times 7. I think that's it. Okay, so here we go. Which one's better? Prime and composite. Perfect and prime. That's the one we want. Right here. Woohoo! So we have 2 minus. We're going to put the square root of the perfect factor first. So square root of 4 times the square root of 7 over 6. Remember, square root 7 is already simplified because it is a prime factor. Here we go. Let's simplify. 2 minus square root of 4, which is 2, times the square root of 7 over 6. Do not do 2 minus 2. You can't do that. But you can go 2 and 6, so that becomes a 1, and that becomes a 3. But remember, 2 and 6, this is a 1 as well. Because remember, it's 2 over 6 minus 2 root 7 over 6. Remember, that's why you can do this stuff, because this is the other way of writing it. This is just more simplified, I guess you could say. Same. That's why you could do this right here. So now our final answer, 1 minus 1 root 7 over 3. So we got to figure out which ones we have to use. Well, we do have to use this first one. Minus this 1 times root 7, you do not need this one. So you have root 7 over 3. And that is number 7. That is OYO number 7. There you go. So if it's a 1 in front of a radical sign, you don't need to use it. If you have 1 in the denominator, you do not need to use it. But if you have 1 just as a simplified term, you need to use it. There we go. I feel like I should do one more. But this video is already pretty long. I'll do more when we get into class. How about that? So, simplifying square roots with properties. If it's put together, you could pull it apart. But if it's also pulled apart, you could put it back together again. So if you get 4, square root of 4 times square root of 7, just remember you could put that together as the square root of 4 times 7. You can put that together, which is the square root of 28. So it's kind of circular in the way that it goes. All right. I hope this was okay. I hope you had enough examples. It's going to take a little bit to get used to simplifying your radicals with non-perfect squares, but remember they can squeak in a perfect square every now and then just to try and trick you. So just make sure you double check. 16, square root of 16. Don't break that down as root 2, root 8. No. Don't even break it down as root 4 times root 4. Because if you do, then you get 2 times 2, which is 4. Oh, by the way, because the square root of 16 is 4. So just kind of double check the numbers that they give you, because they are going to want to trick you on that to see if you're on your toes, I guess you could say, about your perfect squares. So use your factor sheet, your 30 by 30 multiplication chart, because it has all your factors. I will call it factor sheet probably from here on out, I think. Calculators will help, but for me, I like listing my factors. That's going to also help for upcoming chapters. So there's that. All right, guys, I hope you have a great day. Welcome back. Happy New Year. I will catch you later. Be kind.